Transformations. I asked you to look up transformations before Easter. Anybody tell me what a transformation is? Go on then, Julia. Enlighten them since they've been slack over Easter.
A translation.
A translation.
A reflection.
A reflection.
Or a rotation.
Or a rotation. So reflection, rotation and translation are three things we'll be covering, and we'll do something else as well called enlargement. I'm going to treat each one individually, so we'll have a look at them in detail individually, and then I'll give you a worksheet on each one. So, today's objectives. 3 objectives, 4 things to do. First objective, recognise and carry out reflection and rotation on 2-dimensional objects. Okay, bit of fun with tracing paper and some other tricks of the trade. Then we're going to go on to describe translation vectors and use vectors to move shapes around. And then finally,
Pass.
you're late.
Yeah, I'm not wanted.
Oh,
Sorry.
right, let's just go take a seat wherever you can. Try and join a table so you're not on your own.
Yeah,
Sure.
sit with us.
There you go.
Thank you.
Okay, so the third one is talking about enlargement, and we're going to show you how to do an enlargement or find out the scale factor of an enlargement. Okay, so right, that's you done. The recap then, let's get on to the serious thing. Let's get your heads around some maths. I want you to divide £30 in the ratio of 2 to 3, because we're going to use ratios today when we talk about enlargements. I want you to tell me the midpoint of the 2 coordinates 2, 5 and 6, 11. Because today, when you're working out where your line of refraction is, it's between 2 points. And then, how many lines of symmetry and rotation are there in that star? Because in the past, we've done rotational symmetry and lines of symmetry. Who'd like to divide £30 in the ratio 3 to 2 for me?
I'll do that if you want.
Laura?
I was trying to be the best student.
trying to
I
say the
want
hard
I
one
want to
for
spin
you.
the wheel.
Right.
2 plus 3.
2 plus 3. So we've got 5 parts. We need to split this £30, which is a total, into 5 parts. Good.
30 divided by 5.
30 divided by our 5 parts gives us £6 per part.
Oh, 2 times
2 sixes gives us 12 for that side
I didn't get on.
and 18 for that side. And when you add them together, they give you an original 30. Good.
Yeah, it's
Okay. Next one. What is the midpoint of those 2 coordinates? Design.
We know 2
Yeah.
in the first bracket and 6 in the other one.
So what's that normally
X.
called? X. So they're the X coordinates. So we know we've got 2 and 6.
So 8 divided by 2.
And then to work out the average of those 2
4.
gives us an X coordinate of 4. Good.
And then 5 and 11 together.
Which are what?
The Y coordinates.
Good. So the Y coordinates are 5 and 11. So we add 5 and
16.
11 to give us 16. We
Divided
divide
by
by 2 and it gives us
8.
8. So the centre point of those 2 coordinates is 4, 8. If you remember that. If you don't, does it bring back any memories? Yes? No? Deadly silence? Okay, fine. Last one then. How many lines of symmetry and how many orders of rotational symmetry? So how many lines of symmetry does our star have?
1.
1? 1, 2, 3, 3.
I put,
I've been watching that story channel.
I put 5. I said 5.
5. Sold. 5. I'll take 5.
Okay.
I'll take 5.
Down the
Draw a
centre.
line
Yeah.
down the
She
centre.
said it was 5 as well.
Well done.
Just
5.
done symmetry.
Oh.
Good. Just done symmetry. Brilliant. So there are 5 lines of symmetry. You take each point and draw it to the indented bit, and you do that for each of the points. There are 5 lines of symmetry. And how many orders of rotational symmetry?
5.
5.
5. Yeah. So if we put a pin in the centre and we spun it round, it would map onto itself 5 times. Good. And we're going to use lines of symmetry and rotational symmetry in what we're going to do today. Okay, everyone happy with the starters? Yeah, your appetizers. Let's get on to the main course.
Oh my god.
Rain all of a sudden. Okay, we're going to talk about reflection. Okay, everybody knows what reflection is. We do it every morning when we shave. Okay, maybe not.
Mum was shit.
Just me and Harry. Okay. Anybody remember this? A
No.
program called Vision On.
No.
Not got a clue.
Oh no, okay, it's wasted on you then.
You know.
There was a program on TV, okay, and it was called Vision On, And what they used to do in the logo is they used to write vision on reflected, so it created this grasshopper, and they turn it on its down, and it bounced across. And that's how I learned about reflection, because I used to practice writing vision on, and then trying to write the reflection of it underneath to draw the little grasshopper and look that way. Okay, so what we're going to talk about is reflection. Reflection is making an object the same distance away from the mirror as an image. So every point here is the same distance from this mirror line to where it ends up. And we've all seen reflections in various things, in ponds, in rivers, in mirrors and so on, okay? The reflection is always the same size as the image. So it's the object, sorry. So you've got the object and the image. What does that mean? What do we know? What word describes the fact that it's the same dimensions? We've used this word a few times in Unit 3, and it's a Unit 3 favourite word. Buzzword. It's the C word.
Congruent.
Brilliant. Congruent. So if my original shape is exactly the same dimensions as my reflection, then it is congruent. Okay? So it means all of the dimensions are still the same, it's just in a different place. So let's take a closer look at reflection. And we've come across reflection already, because a line of symmetry is actually a reflection. If I have an isosceles triangle being what?
Two sides the same, one different.
You're desperate for that word.
Yeah, I do.
How many lines of symmetry does my isosceles triangle have?
One.
One. Straight down the middle. Straight down the middle. So we've already used reflection, because a line of symmetry is saying if I put a mirror here, what's on that side would look the same as on that side.
Do you mind just using a ruler? It's a little bit off.
Okay. If I take my line of symmetry and I move it outside my object, it becomes a mirror line. Yeah? And if I use that as my mirror line, the technique for reflecting things is to say I reflect things the same distance away from the mirror line from the original. So here I've got my object, we call it an object, and let's call it triangle A. So to reflect triangle A in my blue mirror line, yes?
Can I just say something? You must give the equation of the mirror line.
No, we're coming on to that later. You're a bit too fast.
Oh, am I?
Yeah, we're not on coordinates yet. I'm trying to build your skills. I don't want to scare you. Right? So I'm
Yes,
leading you in gently. So we'll get there. We are coming to
Ask me
coordinates
later
and equations
then.
later. Okay, later. So we've got our object, and we need to create the image in our mirror line. So the trick is, take the corners of whatever it is you're drawing and make sure you hit the mirror line at right angles. See a lovely right angle. And draw the same distance the other side. So I've got that corner there equates to that corner. This corner here would end up somewhere over there. And this corner here would end up there. And when I join my corners, I end up with my image. If they ask you to annotate it, in fact I want you to annotate it, points or the image itself. Anybody know how we annotate it? What do we call it? If this is A, this is A dashed. Might not have seen that before. Okay. And that's how you distinguish between the object, in other words the original, and the image, the reflected image. So the object A, the image A dashed, and we created the image by copying the points the exact same distance the other side of the mirror line. Yeah? Happy with that? Good. So let's build our skills a bit then. So that's basic reflection for you. So let's look at F. Who'd like to come up and draw the reflected image of F?
Go on now.
Yeah?
I'll do it all.
Do you want to do it?
Yeah.
Come on up. Come on up. So we're going to reflect the image F in our mirror line. It doesn't have to be drawn perfectly, just a quick line. I had somebody trying to draw it in all sorts of things yesterday.
Got to make sure that the measurement.
Yeah, a reflection of F, so that's F, that's the mirror line. So what would it look like roughly? Just roughly. Good.
No, you've gone there.
Excellent. Okay. Nearly brilliant. What's missing? What's the only thing that's slightly out? Good. The only thing that's slightly wrong, that's a really, really good effort, I mean, certainly
what
braver
you
than the rest of this lot, is the fact that it's a bit close to the mirror line. Remember the rule, you've got to be the same distance from the mirror line. So, I'll take this perfect F, and we'll move it, oh, I want the mirror line as well, just want the letter F, and we'll move it just so it's slightly further away like that. But other than that, perfect. So can you see how we've got that? Yeah? This point maps to that point, this line maps to that line, and it clips it across. Okay? Again, they're congruent. So the dimensions of the F haven't changed, it's still the same size, but it's just in a different place. That's what congruent means. Okay, now we're going to get slightly more technical. In the exam, they're less likely to just give you an image and a mirror line and say, draw the reflection. They want you to do it accurately, and they tend to put it on the 1 centimetre grids. Okay? So if I said to you, draw the reflection of the triangle ABC, anyone brave enough to come and draw and label the triangle ABC for me? Go on in, Fazana.
I don't mind.
Come on up. Come on up.
Anyway.
Okay.
Am I using
Any colour you like. Green's good for me.
3, 4, 6, 1, 2, 3, 4?
Oh,
Go across one more.
Is it?
There's
You
two
see
from
me,
the
yeah.
line. Two from the
sorry,
line.
yeah.
How do I delete
There's a
that?
rubber there.
Rubber. This thing here. Just do that.
Okay, so let's put it to there. And then
Yeah, just diagonally across to it. Yeah, best you can. Just no marks for it.
is that okay?
Perfect.
Well
Yeah.
done.
And no, I want you to label it.
Okay. All right. Okay. That's a tricky bit. That's going to be C.
Good job.
Yeah.
Yeah.
Everyone happy with that?
Done?
Yeah.
I'm not.
Why?
Why do you
Why
think?
would it?
Anybody spot why I'm not
3,
happy?
4, 3, 4, 5, 6.
It's the labelling I'm not happy with.
Is it? Okay.
What's she not done?
Oh, she's
Oh,
got
the dash
the
above the
dash.
A's, B's and C's. The little dash
Yeah.
above each A, B,
Perfect.
C.
Ah.
Misimperfections. What you need
Dash,
to do
go on.
is A dashed, B dashed, and
Is
C
that-
dashed.
oh,
Yeah,
God.
sorry.
Is that-
See, it's not easy. You think it's easy, but you're not. There's dangers.
Really? Is that what we have to do then in the exam?
Yeah, A dashed, B dashed,
What,
C
like
dashed.
that?
Yeah, because it's an image, and C dashed.
So say if it's
Yeah.
out of 3 marks, you might only get
Yeah.
2 because you forget the dashes.
Absolutely perfect, yes. You would lose a mark if you don't label it correctly. And by putting A, B and C instead of A dash, B dash and C dash, you would lose a mark. Harsh,
Well, I
but
never.
fair.
Harsh.
They need to know the C's from the D's and the E's, and that's how they distinguish it. It's these little things that cost you marks, okay? Happy?
Yeah,
Brilliant.
I'm happy.
Well done.
This is ridiculous, but we live with it.
Okay. Slightly trickier. If they want to be nasty to you, they'll give you a diagonal line to reflect in. But the rule still applies. Everything has to hit the mirror line at right angles. So if I was drawing a right angle to a diagonal line like that, to hit it at right angles, I would have to hit it on the other diagonal. Yeah? See what I'm saying?
Yeah.
To be at 90 degrees. So if I take the 3 points for my triangle here, let's pretend that's meant to be in that corner. Okay? For C, to hit this at right angles, it has to go diagonally across that 1 square and then hit the line. So it's about 1.5 away, isn't it?
Yeah.
So you have to reflect a half, 1.5 away that way. So that's where C dashed lives. We're happy with that.
Yeah.
Yeah.
A lot of people lose track of these diagonals, it throws them. But just hit the mirror line at right angles. So this B has to go diagonally across, so it's 1.5 away. I have to go 1.5 the other side, and that becomes B dashed. Happy?
Yeah.
Yeah.
For this one, it won't be a filled in shape like that because you can't count the diagonals. But it's 1, 2, 3, 4 to that point there. So we'll go 1, 2, 3, 4 to that point there. That would give me, A dashed. And then we create our triangle by joining the bits. Happy?
Yeah.
See what we've done there. So don't let the diagonal line throw you. Okay? Just hit the mirror line at right angles. Okay. Now we can talk about equations of lines and stuff. Okay? So what we've covered so far is around DE level type questions. So we're going to cover the C grade stuff. The C grade stuff will generally be reflection on coordinated graph paper. like that. So you've got x and y coordinates. And what they will do is they'll ask you one of two things. The first thing is they will give you a line of reflection and then tell you to reflect an object in that line. So let's start off. What is the equation of that red line?
0, 0.
Y equals X.
Brilliant.
Oh,
Y
well
equals
done.
x. So this
That's like
line
you.
here is y equals x.
Yeah,
And you
I get
should
confused.
start identifying these now. Yeah? The basics of your graphs is to know the equations of these types of lines. So a diagonal line going that way is y equals x. Diagonal line going that way would be
Is it minus X?
good, y equals minus x. Okay? So they could say square A, reflect it in a line y equals x. You would then be expected to draw that diagonal line and reflect square A in there. So if I do that for you now, it's half away, so that corner's there, so it lives here, and it is A dashed. Can you see that? Yeah?
Yeah.
The other sorts of questions they could give you, let's pretend this is my blue line, is like that. What's the equation of that line?
That's X equals 4, isn't it?
Brilliant. Can people see that? The equation of that blue line there is x equals 4. Because it doesn't matter where I go on that line, the x value has a value of 4. So vertical lines are x equals something. And you have to remember that. Because what they will do is they will give you a square B, and they will say, they won't give you this line, they'll just give you the graph paper and the shape, and they will say reflect B in the line x equals 4. You would be expected to draw the mirror line x equals 4 and then carry out the reflection. Yeah? And then a final check. What's the equation of that line?
Y equals 2. No.
Yeah?
Yeah.
Can everyone see that? So our green line is y equals 2, because it doesn't matter where I go on that line, y has a value of 2. So they could say to you, reflect C in a line y equals 2. In which case, do your reflection and draw your image up there. Okay? So this is where it starts getting into that C grade stuff. This is where they're asking you two techniques. First technique, do you remember how to plot the basic graph lines, y equals x or x equals something or y equals something? And then the second bit is, can you then carry out a reflection in that? If they give you y equals x and it's that, it's the harder one because you've got the diagonal reflection that you need to carry out. And the shape might not be as simple as a square. It will probably be an L shape so that they can see that you flipped it correctly. Okay. So, let's make one up then. Who's brave enough to come up and do a reflection?
I'll come up.
Okay. I'd like you to reflect that blue inverted L in the line y equals 1.
Okay.
And this is the sort of question you'll get. So your first task is,
Draw the line.
good. And when you draw these lines, I go from edge to edge because y equals 1 goes all the way to infinity at each end.
Right, that's
Okay,
good.
so that's good.
Oh, my finger went on there,
That's
sorry.
okay. Yeah, happy?
Yeah.
Looks
There's
pretty
no
good to me.
labelling, so label
No
it.
labelling, so you don't have to worry. If this hasn't got a label on it, if this doesn't say A or B or whatever, then you don't have to do it. Just draw the object. There's no marks for labelling on this example. Everyone happy with what we did there? So they've given you y equals 1, so you're expected to draw the mirror line in the right place and then draw the reflection. If you draw the mirror line the wrong way and you put y equals 1 down there and reflected it the other way, you'd obviously lose a mark or 2 for that. But if you carried out the reflection correctly, you'd get the 1 mark for that reflection. Yeah? See how it works? So this would probably have 3 marks. 1 mark for drawing that correctly, 1 mark for flipping it correctly, and the whole thing is 1 mark. Whereas if you drew the mirror line in the wrong place, you'd probably lose a mark for drawing the mirror line in the wrong place. Okay?
You know, like, you know, in the exam, I think it can get quite tricky because, you know, you've got that line, y equals 1, whatever,
Yeah.
then you've got the axes as well. So if you're in a rush, you could end up like not.
Yeah. You
Here's
can do it the wrong
one for you.
way.
Okay, since we're talking
easily,
about
you
it,
know.
Yeah.
Because
Okay.
you like sort of stress.
what is the definition of the x-axis? If I said to you, I want you to reflect in there, what's the value of that line? What is the equation for that red line? We call it the x-axis, but what's its value? Knowing what you know
Zero.
now. What's 0?
Or is it?
How do you
X
define?
equals 0.
Is x equal to 0? What's this then?
No, it's Y.
Right, that's y
Yeah,
equals
that's
1. That's what
y,
Ali,
yeah,
Ali just
that's
drew.
y.
Yeah.
So what's this?
Y
But-
0.
Y equals 0.
Yeah.
So this will do your heads in. Y equals 0 is the x-axis.
Yeah, I get confused.
Yeah, that's why.
Seriously?
Seriously,
Do your head in a little
I have to
bit.
get my head around
Yeah,
that.
the x-axis is y equals 0.
Yeah, that doesn't.
Conversely,
I find that confusing.
headache time,
X
Well,
equals
X
0.
x equals 0 is the y-axis.
I can't get my head around that.
You just have to remember. it's
Because
the
every
opposite
value
from
of
that
x
one.
is 0
I know.
on the
It's
y-axis.
just the opposite, isn't it?
Yeah?
It's mad.
Okay?
Stupid,
Don't let it
that.
confuse
That's
you.
just stupid, though, isn't it?
It's
Yeah,
not
of course it
stupid.
is.
It's the way it is.
Oh,
Right.
Not happy with that.
Okay.
No, I'm not the only one who thought like that.
The final skill we need to know is if they give you the object and the image, so I've got my square P and P dashed, which is the object,
P.
and the image is P dashed, they might ask you to draw the mirror line and give an equation of that mirror line. So in order to find a mirror line,
You've got to go in the middle, haven't you, Van?
which is where our smart skill came up, you can do it mathematically or you can do it visually. My recommendation, visually. So we're 1, 2, 3, 4, 5, 6 apart, 1, 2, 3. So that's the middle of those 2 points. Yeah? Got this point and this point, 1, 2, 3, 4, 6, 7, 8, 4 is in the middle. So our mirror line is that. So how do you define that line?
Y
equals
minus 2.
Good. And that's how you get your points for that
So
question.
that's alright, but it's the other one, isn't it?
Yeah. Getting this? Time to find out, I do believe. I'm not going to torture you with a video. We're going to do some reflection practice on a worksheet.
Okay, let's do.
In summary, as you're finishing off your last reflection,
X equals 1.
every point is the same distance from the mirror line. And the reflection is the same size as the object. Okay, the original. We're going to move on to rotation now. So if you want to put your reflection stuff away, save it for later. We're going to move on to the second of our subjects and then we'll take a break. So, we've already come across rotation of sorts. We talked about orders of rotation. How many orders of rotation does the object on the left have?
2.
2. Can everyone see that? So I've put a pin in the middle of it and I spin it round, it maps onto itself twice. Next object, if it was an equilateral triangle?
3.
3,
4.
4, and this shape is called a pentagon. Good. So they've got orders of rotational symmetry. So we've come across rotation before, but instead of rotating something on the outside, we've been sticking a pin in the middle of the object and rotating it around its centre. All we're going to do is take that point of rotation and take it outside the object and rotate the whole of the object around an external point. That's all rotation is. Okay. So what do we need to know in order to carry out a rotation? There are 3 things ye must know about rotation. Okay. The first is you need to have a centre of rotation. In other words, where is my point that I'm going to rotate things from? The second, the amount of turn or angle. Okay, because we're doing foundation level, it's 99.9% chance that they will talk about turns. So what's a turn?
It's either going clockwise or anti-clockwise.
No, a
Is it
turn
like
refers
90
to an
degree
angle.
or
No, a
180?
full circle.
Good.
turn.
So a turn is 360 degrees. So a half turn is
180.
180, and a quarter turn is
90.
90. Okay? So at foundation level, you're generally going to get a rotation question that involves a quarter turn or a half turn. Okay? Finally, you need to know which direction you're going to go doing this turn, either clockwise or anti-clockwise. No, it sounds silly. Some people are so young they've never seen an analog face of a computer or a watch or clock or whatever. So you need to tell them which way to go if it's a quarter turn. If it's a half turn, it doesn't matter because you're going to end up at the same place.
And if
aren't
it's
you?
a full turn, it doesn't matter, does it?
Full turn, it's just going to where it is. They're
Yeah.
not going to give you a full turn.
Yeah.
So generally, if you're giving instructions or you're describing a rotation, which you might have to do, then you have to say clockwise or anti-clockwise, a quarter turn, yeah, from the point 0, 0 or wherever. So let's have a look at rotation then. If I've got my object in blue here, there's two ways to do a rotation. There's the easy way and there's the difficult way. Which way would you like to do?
The easy way.
Ah, we like the easy way. The easiest way involves tracing paper. And you take your object and you trace your object and then you stick your pin in the centre of rotation and you rotate it how far they tell you to rotate it. Okay. Let's have a look at this. So, I've got my object in blue, my image in red. So I've rotated my object 90 degrees, or a quarter turn is more likely the way they're going to tell you. Anti-clockwise, that's lefticals, for those of you who can't remember, about the point 0, 0. Let's use my highly expensive piece of tracing paper and do this for you. So the way you would do this, I think I need to lock that. Lock it. Is you would take your piece of paper, draw your object, put your pencil on the centre of rotation, which is 0, 0, go anti-clockwise, 90 degrees, and then plot your image. See how it works?
Yeah.
It's a lot easier than trying to do it mathematically, especially when they give you a centre of rotation that isn't 0, 0, because the maths gets quite difficult. Okay. Yes, they give you tracing paper. And we had to go out and buy some yesterday because the college doesn't actually give us any. It cost 20 pence for an A3 sheet. It's like rare as gold.
I don't think I could do that one without tracing paper.
Which one?
That one you've just done. I don't think I could attempt it without any tracing
Oh, without tracing,
paper.
yeah. That's a straightforward one as well. The things around 0, 0 tend to be straightforward. Okay? So let's have a look at rotation, anti-clockwise, about a different point. So we're not using 0, 0 this time. Same philosophy. Draw your object, stick your pencil on the centre of rotation, and move it 90 degrees anti-clockwise. Now you'll notice the paper, all of the angles on the paper perpendicular. Yeah? See here it's at right angles. When you move it round, that's how you know you've gone far enough. Okay? So the paper's still at right angles, but in a different dimension. Okay, so that's rotation, anti-clockwise through that. Sometimes they might ask you to find the centre of rotation. Okay? They're getting pretty nasty with you now. So all you need to do is trace your object, which is A, and try different places to map it on to B. Quite as simple as that. And there will only be half a dozen options. And when you get the right option, it maps on perfectly. Okay? So that's the tracing paper method to find the centre of rotation. You happy with that?
Yeah.
Good, good, good. This is all going swimmingly. Now there is a difficult method to find the centre of rotation. I say difficult, it isn't really. If you can remember how to do perpendicular bisectors.
Yeah.
I'm looking at you thinking, you remember what
Yeah.
that one is? Yeah?
Yeah.
So if you wanted to
triangle,
find the
you go
centre
up
of
and then
rotation
do
the
the middle
difficult
bit.
way, you take your points here and you bisect the 2 points. Remember how to do a bisector?
Yeah.
Yeah? Take your compass, set the width more than halfway, put the pointy end on one and draw an arc at the top and an arc at the bottom. Put your compass with the same distance on the other point and then draw your arc at the top and your
Just
arc
better
at the
to use
bottom.
tracing paper, really, isn't it?
It is, yeah. When you join it, and you do that for another point, let's say this one and this one we bisect because they map onto each other, you'll find it will go something like that with the 3 points, and they will gather around your centre of rotation. That's the hard way. Stick to the tracing paper. Yeah?
Okay.
Think rotation, think tracing paper. I'd like to summarising on rotation, the 3 things you need for rotation are the direction, whether you're going clockwise or anti-clockwise, the angle or the amount of turn. In your case, they're going to give you a quarter turn or a half turn. Okay? They're not going to give you 43.5 degrees or 27.5 degrees. And where is the centre of the rotation? And it's going to be a nice coordinate, 1, 0, 2, 1 or whatever. So if you have to find the centre of rotation, that's all you have to do with your pencil. Use basic coordinates. Okay? So we've done rotation. We're now going to, that's the first objective done. Next objective, talking about vectors and translation. Okay. Anybody remember these?
Yeah.
These were the equivalent of an Xbox.
Battleship,
I loved it.
Now,
Hell,
when I was a kid,
Battleship.
we used to play battleships with
When you sink
paper.
them.
Then we got to the mid-70s and this came out, and this was like the toy to
Gold
have.
dust.
I cried for a week to try and get one of these off Santa.
You
and
big
it didn't quite
baby.
work. Okay.
Oh.
So this is battleships, and battleships used to, remember you used to play it B4. You saw my cruiser, yeah? You'd go along and across and you'd sink things through things. When we're talking about translation, we're going to be moving things around, and you need to give instructions on how to move things around like a battleship, okay? We've come across X and Y's before, and when we used to write coordinates, and you've just done it now, centres of rotation, it was in the format XY. Yeah? So a coordinate is the X coordinate and the Y coordinate, and it's in brackets and it's horizontal. This thing called a vector tells us how to move objects or points around in mathematics. And you can spot a vector a mile away because the X and the Y are above each other. One's above the other. The X is above the Y. There's no line, it's not a fraction. There's no comma, it's just an X and a Y. And those X and Y's don't tell you a position, they tell you a certain direction and amount to travel in. So the X tells you to go left or right. So if it's positive, if it was
Go right.
3, 2, you go right because it's positive
And
and
up.
up because the Y is positive.
And
Okay.
if it's negative,
If it's
you go
negative,
left
minus
and down.
2, minus 4.
Left and down.
Minus 2 is left 2, and minus 4 is down 4. And that is vectors. So whatever it is you're moving, the vector tells you where to go. Or conversely, if they've got an object and an image, to work out how it's moved, you only need to take one point and work out how far across and up or down it's gone. Okay? So please be aware of the format of a vector. A lot of people are getting this wrong when they're doing the worksheet that I'm going to give you in a minute. Okay, so the X is above the Y, there's no line, so it doesn't look like a fraction, it's just an X value and a Y value in these big brackets. Okay, and it's different from a coordinate, which is the X next to the Y, and that's where people get confused. So, again, it's a congruent process. Our object and image have got identical dimensions. So it's our third congruent process. Rotation, reflection, and translation are all congruent processes. Nothing happens to our object. Okay? So let's have a look then. So this is the instance where I've given you the object and the image, and I want you to tell me what vector moved that object to the image. So like I say, you just pick one point. Pick a point.
C.
Point C. Point C. So all you have to ask yourself is, how did I go from the object to the image, the C to the C dashed?
Across 4.
Across 4. 1, 2, 3, 4. So in my vector, what do I put here? 4. Because I've gone 4 to the right. And then
3.
3 up.
1, 2, 3 up tells me I've gone 3 up. Now you only have to do it for one point because all of the other points move exactly the same amount so that your image is exactly the same size as your object. So the beauty of vectors is you only have to do it for one point and that vector describes the whole object. Yeah?
Mm-hmm.
Good. Conversely, they could give you a point, like this orange dot, or an object, like our grey square, to move around, giving you a vector. So if I've got a vector of -2, -3, what's going to happen to my orange dot?
Gonna go left,
Left.
Left,
and down.
Down.
left how many?
2,
Left 2,
down 3.
down 3. And that's where my orange dot ends up. So you can see how vectors work. Nothing hard about them. So if you're given the object and the image to calculate a vector, just pick a point. If you're given an object and you have to create the image, just do what the vector tells you to do. Happy?
Sure thing.
Sure thing. The vectors are done. That's all there is to vectors and translation. I'll give you the worksheet.
Perfecto.
You've got to get these vectors correct with the format. Lefty righties is the top value. Uppy downies is your second value. Don't get your uppy downies confused with your lefty righties.
Oh, I'll have to do it that way.
Okay, just want to finish off the question you're on. We will continue with the last bit of the lesson. So in summary for translation, translation moves a whole object or a point by given instructions. The instructions appear in a vector. The vector tells you how far lefty righties to go at the top and how far uppy downies on the bottom, or the x value and the y value. And it moves the whole object, and the object doesn't change dimensions, so it's congruent. You will remember congruent if it comes up. Okay, so that's the second objective for today done. If you like to heads up, look at the board, we will continue with enlargement.
Okay.
My most disliked tool on the planet, PowerPoint. Okay, going to talk about enlargement. Enlargements increase or decrease the size of something by a given scale. So you have to say how much it's going to change by. So what is it not? Congruent. So if it's not congruent, it's the other word that we did a few weeks ago. Anyone remember? Begins with
Similar.
S. Similar. Okay? So if it's not congruent, it's similar. So they're similar. Sometimes you're given a centre of enlargement. Other times they won't. They'll just give you an object and say enlarge it by a scale factor of 2 or 3. Other times they'll say using point A, increase the size of something by a scale factor of 2 or 3, and that requires a particular skill. Or they'll give you an object and an image and tell you to find the centre of enlargement. So these are the points that we're going to cover now. So the harder stuff involves these centres of enlargement. Ooh, spooky. Okay, so what do we know about enlargement? It makes a shape bigger. The ratios for all of the sides remain the same. So a homework you had a few weeks ago had a rectangle and another rectangle, and it said prove that it isn't an enlargement. And one of the sides had a different ratio from the other sides, and that's how you prove it's not an enlargement, because everything has to go up by the same scale, all of the dimensions. Okay? Call the original shape and the enlarged shape similar, so it's not congruent, it's the one that isn't congruent. Before we do the enlargement, we need to know what scale, and that scale is like a ratio. You know, when we do our ratios, what we're multiplying each side by, that's what we call the scale factor. And then finally, I know it sounds weird, but you can enlarge things so they become smaller. Because if you have a scale factor smaller than the value of 1, the shape will decrease in size. Okay? So, in theory, an enlargement can involve shrinking something.
Weird.
Yeah.
That is weird.
Weird. Okay. Let's put this in context then. I've got my original picture, my little picture I've taken of dolphins, Florida I think that is. And it's 3 by 4. Okay? Go to the photo booth and I say I want it enlarging. So an enlargement has increased this side from 4 to 12. So what's my scale factor? 3.
Three.
So what do I have to do with the
Times
side
that
that's
by
missing
to get 9.
Times it by 3.
to get
9.
your 9? So that's an enlargement. They can give you a question where you have one of the sides of your object and you have both of the sides for your image. So in this case, I've gone from 5 to 12.5, which is a scale factor of 2.5. So what do I have to do to the 10?
Divide it by
2.5, and that gives me
4.
4. Brilliant. Took about 15 minutes last night to get that out of them. Okay.
You know where your best class you've told us, I don't know how many times.
Did I not take that back a couple of weeks ago?
No,
Sure I did.
you never.
Right. So let's look at some basics then. Let's look at the DE level questions. You've got object A, image B. How do we know they're object and image?
because they've got the dash.
The A is the object, the A dashed is the image. And they might say something, and you'll get something as simple as this. What is the scale factor that I've increased the size or enlarged A to A dashed?
Times 2.
Times 2. The best way to get a scale factor is just pick one dimension. For example, this side here. And that's got a length of 1. And if it's gone to 2, it's just doubled it. All the questions they'll give you on enlargements will come on that lovely 1 inch centimetre
Gridded paper.
square paper. Yeah, so you'll be able to see it straight away. So just pick one of the dimensions and see what's happened to it to work out the scale factor. Okay. So here we've got a slightly more complicated shape, but don't let it phase you. So what is the enlargement from B to B
Times
dash?
3.
3, because I've gone from 2 to 6. So my scale is 3. Can you see that?
Yeah.
Quite straightforward, isn't it? Good. Okay, so here are 4. Have a go at those 4 on your own, and then we'll go around the class and we'll share the love. I'll spread the questions around. Okay, so what are the enlargement scale factors for those 4 questions? A to A dashed, B to B dashed, C to C dashed, and D to D dashed. So at the moment we're kind of working in the D area of geometry. In a second we'll move it out to the C.
Okay.
We done that?
Yeah.
Crocky.
You're not finished yet. Happy days? Okay, lefties. What's my scale factor? 2. Everyone get 2?
Yeah.
For B, centres.
1.
By
Go on, do you want to say you got it right?
You're right.
Times by
2. Because we've gone from 2 here to 4 up there. So the scale factor's 2. C, righties. 3, because it's gone from 1 to 3. And then finally lefties. 4, because we've gone from 2 to 8 across the top. So always pick a dimension that's easy for you to do that with. Don't go for a diagonal or, you just do your heading and just pick a nice, easy one.
I always went for the diagonal.
Good. What's the enlargement scale factor for that then?
2.
2.
What's the object?
It's reducing by 2.
Oh,
It's
minus 2.
reducing by 2. It's not a minus. What did I say? If it shrinks.
I don't know because I wasn't really listening.
Sorry? To make something smaller, if you're multiplying by 1, it's the same. By 2, it gets bigger. So, sort of dividing by 2. So what does that mean then? What's the same as dividing something by 2? A half. So the scale factor is a half.
Okay.
Because we've gone from 2 to 1. See how that works? So the scale factor when something decreases in size is going to be less than 1. And you'll only get a half at the foundation then. Yeah?
Perfecto.
Perfetto mondo. Sì, molto bene. We're going to do centres of enlargement. This is the C grade stuff. We're moving out of the comfort zone of green and we're into the blue. Okay? A centre of enlargement, they'll give you an object and they will say something along the lines of, using the centre of enlargement A, we'll call that point A, enlarge that square, or sorry, that rectangle by a scale factor of 2. Now because they've given you a centre of enlargement, everything has to be done with reference to this. Okay? So that's the important about a centre of enlargement. So let's look at it. The way you do in a centre of enlargement to a scale factor of 2 is you double the distance of everything from that point. So I am 1, 2, 3, 4, 5. 5 away that way and 2 up. So this corner here is going to end up where, do you think? With a scale factor of 2, how many across am I going to go?
10.
10, 6, 7, 8, 9. That takes me to 10 across. And how many up do you think?
4.
1, 2, 3, 4. So that corner there is going to end up on this corner. Now you have two options. You can do the same for all of the other corners, or the
Just draw
preferred
it.
option, now that you've got somewhere to start, just increase this by a factor of 2, your original square. So if it's 2 up, how many up am I going to go?
4.
4.
If it's 3 across,
6.
6.
if it's 2 up or 2 down, it's going to be 4, and there you go. So that's the easiest way to do an enlargement when they give you a centre of enlargement, okay? So you have to start here and work out where your first point is. When you've worked out where that point goes to, in other words, doubling everything or tripling it, whatever instructions they give you, you know where it lives, and then you can just increase by a scale factor of 2 or 3 or whatever. That would be my preferred method of doing it. Does that make sense?
Can't you just go ahead and double it all instead of like...
You can. So you could then say this corner here is 1, 2, 3, 4, 5, 6, 7, 8 away and 2 up. So it becomes 16 away, which is there, and then 4 up. So that would put that there. So there's two ways of doing it. So you're doing it the other way. I'm suggesting it's easier to just find a start point and double the dimensions of your square or your rectangle or whatever the shape is.
You're
Stop
making nice
confusing.
I know, I don't know.
Does that make sense? Yeah?
Understood.
So
I'm trying to give you the easiest way of doing everything. I don't want to over confuse things for you. But you can do it that way, there's nothing wrong. Take
Oh, I'll
each
do
point,
the easy way.
5 along and 4 up would become 10 along and 8 up, which would end up there. You get the same results. Okay? Right, it might work the other way. Let's hide this. And they might give you the object and the image, and they will say to you, find the centre of enlargement. Spooky stuff.
So just work backwards.
All you need to do is not work backwards, is to join the corners that correlate to each other. So, can I clear the ink? Excellent. All you need to do is get rid of this ink page on PowerPoint, which is ridiculously stupid, and join the corners that correspond. So this corner is the same as that corner is the same as that corner, and that corner is the same as that corner. And where they meet, it gives you your centre of enlargement. Take a bow now.
Yeah. Curtsy, please, curtsy. Thank you.
Okay. So, what was it? Okay. So, if they give you an object and an image, so that's our object and image, and they say find the centre of enlargement, what are you going to do?
Join the corners.
That correspond with each other.
That
And
corresponds.
there's your centre of enlargement.
Magic.
Isn't that easy peasy? No calculations, just a few lines. If they do that to you, so our object is our small rectangle and our image is our big one, so one's inside the other, when you do the same thing,
Do it that way.
join the relative corners, the centre of enlargement is actually inside your object. There's no reason why it can't be, so don't let it phase you. Just the way to find the centre of enlargement is straight line between the corresponding corners, and that will tell you where your centre of enlargement is. Okay? So centre of enlargement is the harder questions with enlargement. Okay? I think that's it with that. So I'm just going to go through that one more time on something I did yesterday, just to make sure it's gone in. Okay? So I've got point A, and I've got my rectangle, and I'm going to increase the scale factor of my rectangle by a scale factor of 3 with respect to my centre of enlargement, which is point A.
Okay.
Yeah? So what's my first thing I'm going to do?
Find the point that you're going to use.
So find the point I'm going to use.
So
I'm going
one-
to choose this one,
yeah.
shall I? Yeah.
One across and 2
So
up.
how many across?
1,
1 across
2 up.
and 2 up. Can everyone see that?
Yeah.
So I'm increasing by a scale factor of 3. So 1 across becomes 3 across. 1, 2, 3. And 2 up becomes
6.
6. 1, 2, 3, 4, 5, 6. So that corner there now lives there. Pete's preferred method, reconstruct your rectangle based on a scale factor of 3. So if it goes 2 up on the original, how many up am I going to go?
6.
6.
If it goes 3 across, how many are going to go?
9.
9.
9, 6. And I have increased my original, my object, by a scale factor of 3 relative to my centre of enlargement. Does that make sense to everybody?
Mm-hmm.
Yeah? Ready for your last worksheet, your last bit of work
Yeah,
today?
let's rock and roll.
We today have covered reflection,
With the ribbons at the end.
rotation, translation and enlargement. They're called the transformations as a group. Okay? Any questions on anything we've done today?